Today we're starting off our chapter number 2, which is all about polynomials and a little bit about rational functions. So we're talking about polynomial functions, their characteristics, their qualities, things that we can analyze. And today we're starting off with quadratics, which is really a simple kind of polynomial, and we've studied this before. So a lot of this information is more review than new. We're going to be talking about graphing these by hand, by finding the vertex, the intercepts, finding the 5 points, and using that line of symmetry to get one of those points, and we'll graph that here as well in just a moment. So we're starting off with what our book calls the general form. Here we've got all the terms on the same side. And so you can see here we have our leading coefficient of A. There's the B, there's the constant term of C. What we want to do is start by finding the vertex. And to do that, we're going to start by finding this line of symmetry, which is the equation of a vertical line when you just have an x. So for the line of symmetry, we will have x equals a very specific number. We're going to calculate that in a moment. But just remember that's the equation of a vertical line. So it's not just the x-coordinate on the vertex. It is that, but it's also this vertical line. So we're going to find that by the opposite of b over 2a. So the opposite of the value b is a negative 6 all over 2 times a. A is that negative 1. So we get a result of negative 3. So that's going to be where the line of symmetry occurs, as well as the x-coordinate of the vertex. So now to find the y-coordinate of the vertex, we're going to substitute that x value that we just found right back into the equation to find the y. So here it's listed as function notation, but that's my output, which is the same as the y-coordinate. So that'll be negative 3 squared minus 6 times negative 3 with that plus 7. So this value of x, that's what our input is. You can see that's where we plugged it in. With that as our input, then our output will be 16. So that means we have a vertex located at negative 3 comma 16. So that line of symmetry will be the vertical line that goes right through this point. So to fit that on the graph, I need to go up by 2's on my vertical axis. I'll just go by 1's on my horizontal axis. So that'll give me a placement of negative 1, 2, 3, and then up 2, 4, 6, 8, 10, 12, 14, 16. There's the vertex of the parabola, and then here's my line of symmetry. There's my vertical line, whose equation is x equals negative 3. So we'll use that in a minute. All right, let's find the x-intercept. So we've done this work before. You might remember in order to find the x-intercept, what we have to do is to get rid of the y. Set y equal to 0. So that means I'm using this. So this is the output. That's my y-coordinate. So 0 equals negative x squared minus 6x plus 7. It's a quadratic. We've learned you can use the quadratic formula or factoring. I'll use factoring here. But I'm going to divide everything by a negative 1 because when I factor, I want a positive on my x squared. It's just easier for me to factor. And if that's the same for you, that's a little trick. Divide away a negative 1. Factors of negative 7, they have to add up to a positive 6. So positive on the 7, negative on the 1. Separate each factor, setting each equal to 0. And so that means we have x equals negative 7 and x equals positive 1. I'm running out of room here a little bit, so let me just kind of summarize my x-intercepts here in the next column. List them as ordered pairs. So when it says x equals negative 7, let's write that as negative 7 comma 0. And then that should be a positive 1 right there. Positive 1 comma 0 for the other. So plotting my x-intercepts. There they go. So with those 3 points, we already see that our parabola is opening downwards, but we want 5 points, not 3, so let's find the y-intercept next. To find the y-intercept, that means get rid of the x. So set x equal to 0. So y equals negative 0 squared minus 6 times 0 with a plus 7. So as you input the 0, that first term drops out, the middle term drops out, the constant term is the only thing that remains. So that means I have a y-intercept at 0 comma 7. So 1, 2, 3, 4, 5, 6, 7, there it is. So that's 4 points, but we want 5. And so the very last step is to reflect that y-intercept over the line of symmetry. So just count that distance. That is a distance of 3 to the right of the line of symmetry. So 1, 2, 3 to the left. That's where the reflected point is located. Now that we've got all 5, draw a smooth curve through those points. So there's our parabola opening downwards, with the line of symmetry identified and that reflected 5th point. So that is using what we call the general form to find our vertex and the intercepts. But we can also have what we call this standard form. That's what our book calls it. I like to call it the vertex form, actually, because it's set up in a way where we already have the vertex identified with the h and the k. We used this when we were graphing with transformations, using a reflection, a stretch, and a translation. We're not using that method here, although it could still apply. Instead, we're going to identify the vertex right away, and then we'll find our intercepts. So the vertex is h and k, but remember you always change the sign on the h. So it looks like a -3, it's actually a +3 in its placement. Let's find our x-intercepts. So again, to do that, get rid of the y's, set y equal to 0. So your output is 0. So we have a -2 times that quantity, x minus 3. That quantity is squared with a +7. So here we don't solve by factoring. We don't use our quadratic formula like what we did up here with the factoring method. Here we just work to isolate the variable. So let's get rid of the constant term, subtracting 7 from both sides, and then dividing away the -2. So now we have a +7/2 on the left. On the right, we have x minus 3 quantity squared. Get rid of that power of 2 by extracting the roots. So you want to make sure you have a plus or minus on that radical. However, do you remember that we are not allowed to keep a radical on the denominator? So we have to rationalize by multiplying top and bottom by √2. X minus 3 is on the right. So on the left-hand side, this will turn into plus or minus √14 over normal 2. And then to isolate the x, let's add 3 to both sides with a +3. So notice we have different denominators. We could create a common denominator of 2. I'm just going to leave it this way. But in terms of plotting that point, I don't know where that is. So let's use our calculator to get a decimal value. I'll summarize the results up here in the next column. So my calculator tells me I have a decimal value of 4.9, as well as 1.1, 0. So on my graph, my scale will be 1s on both axes. So let's see, we have a vertex at 3, 7. And plotting the x-intercepts. It's a fairly narrow parabola. Our line of symmetry goes right down the center. It's like a center line. And it goes right through the vertex, right? So if we had to write the equation of that line of symmetry, that would be x equals, and the x-coordinate is 3, so x equals 3. So to finish it up, we need the y-intercept. So to find the y-intercept, get rid of the x, set x equal to 0. So 0 is your input. So y equals a -2 times the quantity of 0 minus 3. That quantity is squared with a +7. So using order of operations, we have a -3, and then we square that, we get a +9. Then we multiply that with a -2, -18. Then we add 7, and that gives us a result of -11. So my y-intercept is located at 0, -11. I just barely made it right on the graph with the grid that I have. So again, count that distance from the line of symmetry. That's 1, 2, 3 spaces away. So 1, 2, 3 spaces on the other side is the reflected point. There's our 5 points. And there's our parabola once again opening downwards. So So that's topic number 1, taking a look at graphing these things using the two different forms, what we call general form and standard form. So we have a couple more topics. Let me turn to page 2, do a couple more examples here. In example number 3, we're going to convert from one form to the other. And we're going to convert from general form, that's what we have here, to standard form. Again, that's what I like to call the vertex form. That's the one with the H and the K. And I'm going to use these examples here to really just focus on the conversion. We'll identify the vertex, but I'm not going to find those X-intercepts. We did that on page 1. So when we convert from one form to the other, that's another way of saying just complete the square. So again, this is a skill we've practiced before. And even though they did not spell out the method, that's the method we have to use to convert the form. So again, here's your A, here's your B, here's your C. So the very first step that you have to do is if you have a leading coefficient that is not 1, then you have to factor out that number of A. Well, A is just 1 in this case, so you factor out a 1 and nothing happens. So we're moving on to the next step. Notice we're not dividing every side. We're just factoring it out. And we'll see that in more detail here in part B when that leading coefficient is not 1. And that's because we don't have a 0 on the left-hand side. If we had a 0, then we could divide both sides by that leading coefficient, but that's not the method we're using here. Second step is we're going to add and then subtract right back out again on the exact same side that magic number of b over 2 quantity squared. So our value of b is 3. So for us, we're going to use a 3 over 2 quantity squared, which means we're talking about 9/4, adding and subtracting 9/4. So again, we're not adding 9/4 to both sides of the equation because I don't have a number on the left-hand side. I just have this function notation on the left-hand side. To set this up, you want to take your constant term and push it to the right-hand side, giving yourself some space in the middle. This is where we add the 9/4 and then subtract the 9/4 right back out again to keep the equation balanced. So instead of adding 9/4 to both sides of the equation, we can't do that because we don't have a 0 on the left-hand side. We're just adding and subtracting it right back out again. So our next step then is to factor the trinomial. And the last two terms, we will combine those like terms. So that's our next step. We're going to factor and combine. So we'll combine those like terms. So let's start off with the factoring piece. That's a trinomial, so let's set up as a binomial squared. X in front. We have a fraction in the back, so we want a fraction in the back. So think about what numerator squared would give you the 9 that you see right there, so we want a 3. 3 squared is 9. What denominator squared would get you the 4? You want a 2, because 2 squared is 4, right? Check the middle term. It's a positive on the 3x. You want a positive here as well. So if you were to FOIL this back out again, those are the 3 terms you would end up with. Here, combining like terms, we need a common denominator of 4. So we're going to take a moment and multiply that 4 by 4 over 4. So we have a common denominator of 4. So here we have a negative 9/4 plus 16/4, and that gives us a result of positive 7/4. So here is the H and the K. Again, you have to change the sign on the H when you take that out. So the vertex is located at a negative 3/2, comma 7/4. And if we go a step farther, that line of symmetry would be x equals negative 3/2. So let's take a look at another example of completing the square when our leading coefficient is not 1. Here it happens to be a negative 1. So let's see what we're doing here. Here's the A, here's the B, here's the C. So again, step 1 is to factor out that A. So again, we're not dividing it away, we're factoring it out, which means it's just going to sit there on the outside. Now you have a positive x squared, a negative 6x, and a positive 8. Then we're going to find that mystery number. So let me get this set up by moving the constant term a bit more to the right, giving myself some space here. I'll put the plus 8 a little farther to the right. Don't lose these parentheses. We need them all the way through because this negative 1 is being multiplied to everything that's on the inside. So we want to think, what is this magic number? We want b over 2 quantity squared. Our value of b is it's a negative 6. Right? So it's not the positive 6 from the original. Now it's a negative 6. So negative 6 over 2 squared. And when you square negative, that turns into a positive 9. So we are going to add 9 and then subtract 9 right back out again. So we have the first 3 terms, which is the trinomial that will factor, and the last 2 terms will be combining as like terms. So there's a negative 1 on the outside. Now again, don't lose these parentheses because that negative 1 has to be multiplied to everything on the inside. And we're just changing the form of this trinomial into a binomial square. So you'll have these nested parentheses. You want a negative sign in the middle there. Negative 9 plus 8 is a negative 1. And here's the very last step. Take that negative 1 that we had factored out and multiply it right back in. So negative on the x minus 3 quantity squared and a positive on the 1. So here is my h, here is my k. So my vertex is located at positive 3 comma 1. And that means my line of symmetry is x equals positive 3. So finishing up, what we're doing with this last example is we are now going backwards. They are giving us the vertex and some other information, this point on the parabola, and our goal is to find the standard form. Now again, that standard form is what I call the vertex form. And so there it is. There's the vertex form with the h and the k. We're going to plug in our vertex for h and k. We'll plug in this extra point for the x and the y. Now that's function notation that you see there, but that's the output. So you can think of that like an ordered pair of x and y. And our goal is to solve for the a. That's the only thing we don't know. What's the vertical stretch on this? So here's the h and the x. The h and the k for the vertex. 2 comma 3 then is this point on the parabola. So that's the x and the y. So what you see here is the function notation. You can replace that with the letter y if you want. I'm just writing down the formula again, and let's drop in all of our values. So y is 3, a is the unknown, x is the 2, we're subtracting h is the 4, and we're adding k, but k is negative, so think of it like adding a negative 1. So order of operations tells me I need to focus on the grouping symbols here, with a negative 2 on the inside. Then we'll square that negative 2, and that becomes a positive 4. Now be very careful here. Don't make this mistake. Don't think you're going 4 minus 1, because those are not like terms. If you like, you can flip-flop these around, put that 4 in front as a coefficient should be. Right? You can't go 4a minus 1 to turn that into a 3a. That doesn't work. Instead, you have to combine your constant terms. So add 1 to both sides. So you have 4 equals 4 times a. And lastly, a equals 1, which means there's no vertical stretch or shrink at all. So as we take that information to write the standard form, our function is, okay, normally we don't write the 1, but just to kind of emphasize the fact that, yes, we did find it, and I didn't forget a step, there it is. And then we want the h and the k. So x minus the h value of 4, quantity squared, and k is a negative 1, so minus 1. So there it is, the standard form.